hello. Besides, this is the outside. That's okay. It is source of 192.168.1.1 on the inside, 224.0.0.10, which is EIGRP. But now how do I know it's a hello packet besides the header over here? If you open this packet up, this is what a EIGRP hello packet looks like. Again, it's clear text, but it's getting propagated across. This is my AS number that I used. What's the size? 98 byte size, and that's what I'm showing you over here. Overall, everybody understand this packet? It's a GRE packet, outer header, public addresses, inner header is my GRE, EIGRP packet. In my case, the address is 1. Yeah? GRE good? What's the drawback of this? Although I did take care of the dynamic part of the IPSec drawback, the problem is this is all clear text. I showed you the packets. I showed you your ping packet. I showed you an EIGRP hello packet. Everything is in the clear. Yes, it's encapsulated, but I can see this data. There's a difference between encapsulation and encryption. Yes, I'm encapsulating it. Encapsulating means what? Putting one packet within another packet. I am doing that, and I showed you that, but I'm not encrypting it. It's clear text, so you can actually see the packet. Clear? The interface has no issue with multicast. The tunnel interface has no issue with multicast. So when you enable EIGRP on the tunnel interface, it'll send any packet. So once the packet is set on the tunnel interface, it knows it needs to encapsulate. Got a trend? So the drawback of this is that it is clear text. So what they said was that this is okay, but the problem is I want confidentiality of the packet as well. And that's where IPSec steps in again. It says, okay, what I'm going to do is I'm going to take the GRE packet, complete GRE packet, which has the public addresses, and then I have my inner header. I'm going to take the entire packet and encrypt it using IPSec. So the entire packet over here will be treated as data and encrypted. And this would be called GRE over IPSec. So I get the routing portion taken care of by the inner packet. IPSec's job is any traffic that hits the tunnel interface, I'm going to encrypt it. I don't care how. I don't care about the interesting traffic. GRE does the routing. It tells me that the traffic hits the tunnel interface. Anything on the tunnel interface will be encrypted. Understood? How do I do that? I'll show you that. But the purpose over here is to encrypt all that traffic. So I've done that for you guys as well in a slide. I don't promise slides for everyone, but whatever I have, I will provide. So this is GRE over IPSec. Although GRE connects two private sites to each other over the internet, the data is sent in the clear text. They have the ability to encrypt all the traffic that leaves the tunnel interface using IPSec. This is known as GRE over IPSec. And that's what I'm going to be going over here. I'm going to take this tunnel interface and slap it with what? ESP. So it encrypts all the data. Okay. How do I do IPSec? Do you guys remember the morning lecture for IPSec? Or for some of you guys, night? It depends on what part of the world you're at. the whole thing, right? Crypto map was one aspect of it, phase one, phase two, right? Tunnel one to set up the secure tunnel to exchange the session key securely. Tunnel two was the encryption part of it, right? I need to do the same thing over here. So now what I'm going to do is lab number 4. This one is done, or 4 is done. 5 I need to do now. Number 5. Encrypt all the traffic that leaves the tunnel interface by using IPSec. And what is this called? GRE over IPSec. How do I do it? You guys remember your IPSec commands? What was the first thing that I did with IPSec? Do you guys remember that? What's the first thing that I need to do with IPSec? Remember the 5 steps, right? ISACAMP, perfect. So phase 1 is ISACAMP parameters. What are the parameters for ISACAMP? Crypto ISACAMP policy, give it a number, doesn't matter. Authentication, pre-share, hash MD5, group 2, encryption, triple des, and my crypto ISACAMP key, Cisco 123 address, the public address of the other side. Good so far? Remember the 3, key, encryption, and hash. And in the first tunnel, my information that I'm exchanging is my session key that was generated by, actually, let's put this at the end so you guys can see. It doesn't matter what order you put it in, but just for that. Good. What was the second step? PSEP, the ESP parameters, right? So at this point, I would have the session key exchange. Now I'm ready for my second tunnel, crypto, IPSec, transform set, PSET, whatever you want to call it, ESP, MD5, whatever parameters you want to use for this one. Good so far? Done. Third step. This is where a slight change comes in. What was my third step in the previous example? The normal crypto map part. The ACL, the interesting traffic was the ACL, right? Here, what am I saying? Any traffic that goes over the tunnel should be encrypted. So I don't need the ACL. Agreed? I don't need the ACL. Why? Any traffic that goes over the tunnel interface will be encrypted. So no ACL required. The routing protocol would be taking care of that. What I need though is a component, configure an IPSec profile. You will attach the transform set to it. The profile later on will be attached or applied to the tunnel interface. Now, I have a question for you guys. Do you guys remember the crypto map? For the crypto map parameter that was applied to my physical interface? What were the parameters in the crypto map? Here, which is the destination, ACL, and the transform set. Agreed? And I applied this to my outgoing interface. Now over here, we've already said that I don't need an ACL, right? All traffic will be interesting traffic. Correct? I don't need the peer. Why? The interface already has a tunnel destination. 200.111 in my case, right? I don't need the peer. So what's the third thing that was inside the crypto map? Which transform set we use, right? That's why I define the IPSec profile. In the IPSec profile, I will specify whatever you want to call it. I call it iProf. Set the transform set to DSET. So what am I attaching to my profile? The transform set. So on my outgoing interface, I had a crypto map which had three components: the peer, the ACL, and the transform set. I don't need a peer, I don't need an ACL, I need a transform set. So all I got to do now is number 4, apply the IPSec profile to the outgoing tunnel interface. I'm not using the physical interface, I'm going through the tunnel because I want to encrypt all the tunnel traffic. How do I do it? Interface tunnel 1, tunnel protection, which basically says any traffic leaving this tunnel interface should be protected based on the IPSec profile called iProf. Understood? That's your apply. So to do GRE over IPSec, there's only 4 steps. Phase 1, phase 2, the IPSec profile, and apply the IPSec profile to the tunnel interface, which basically says any traffic leaving the tunnel interface should be encrypted by using this particular transfer set. It automatically calls the ISACM key, because when you do the IPSec profile, the keying is done using the ISACM policy. So 4 steps to do GRE over IPSec. Questions? Any questions about this? Yes, no? Automatic. You don't need to specify it. It automatically calls. So whenever you apply an IPSec profile to your, tunnel interface, it automatically, if there's no session key there, it'll automatically invoke the profile and look for the address that's my tunnel destination. What the packet looks like, I'll show you that. So I'll actually show you the packet format in a second. All good at this point? All right, let's do it. So I'll do this on R1. Copy it. Now what's going to happen when I do this? One side is encrypting, the other one is not. So my EIGRP neighbor relationship will go down. The peers remain static. The traffic in terms of new networks getting added becomes dynamic. So now my EIGRP will go down because of what? One side's encrypting, the other one is not. So how do I get around that? I need to do the same thing on the other side. Get used to doing it in Notepad because that saves you a lot of time on the exam. Router 2, using the same parameters, my address will change. The rest remains the same. Take a look, the 4 steps. Phase 1, phase 2, IPSec profile, and apply the IPSec profile to the tunnel interface. Everybody good with this? Can I go ahead and apply this to router 2 and see if my tunnel comes up? See, the tunnel is down, or the EIGRP neighbor relationship is down. Boom. EIGRP back up. And because I've told it, any traffic leaving the tunnel should be encrypted based on IPSec, it's encrypting it as well. My tunnel has come up, show IP route, I've restored it back to what? I have 10.1, 10.2. This guy should have 10.1, 10.2, and it also should have that 172.6 network because on one side I have 192.116, 116, 10. Now, before I go on to this, this is how you do it. Phase 1 parameters, phase 2 parameters, the IPSec profile, and then apply the IPSec profile to the packet. Now, before I go into this, I want you guys to go back and check my packet format. You guys remember this? Hello packet was what? 98 bytes. I showed it to you. Yeah. Now, over here, I'm going to take the entire packet because I'm going to use this as a sample. I'm going to take the entire packet because I've told ESP that any packet that hits this tunnel interface, which is this is what the packet is going to look like, encapsulated with ESP and encrypted. So not only encapsulated, treat this as data plus encrypted. Encapsulate and encrypt. So the packet goes from 98 bytes to looking like this. Take a look at it and tell me if you guys are okay with that. So it takes a look at the tunnel, source, tunnel, destination, and uses that as the outer source and destination of ESP. This packet, the entire packet over here, is treated as data, including the GRE header and the EIGRP header, and encrypted. So if somebody runs a sniff, he will just see ESP and data. He will not see any of that. But the packet format would have changed, or size would have changed to 150 bytes. Where's the inner source in EIGRP hello packet? Inner source, this is your EIGRP hello packet, source and destination. If you're thinking about ping, ping will not use EIGRP packet. If it was a ping packet, then this packet would not be an EIGRP packet, then it would be an ICMP packet. If that's what you're thinking. Hello packet is different, ping packet is different. So in that case, the ICMP packet is your inner header, not EIGRP. But I'm just focusing on that hello packet because I can work with the size. Understood that, Abdul? You guys are okay with this packet format? Can you see that in Wireshark? Absolutely. And you'll notice that I have a constant ESP packet coming across. Take a look. It is using the protocol ESP. If I expand it, it doesn't show you anything. This shows you the source is 201 to 99 or 199 to 200. Doesn't matter which one. So it just shows you the outer header. It doesn't show you the inside. But what I want you guys to take a look at is the size. What did the size go on the EIGRP hello packet? I cannot tell you definitively that this is EIGRP hello, but I'm not sending any data. So the only data that is getting sent across is your ESP packet. That has to be the EIGRP hello. It's encrypted, so I won't be able to go inside it. So this part over here is what is getting encrypted. Understood? Perfect. So now the packet size has increased by how many bytes? What's the IPSec header going to be based on what you just saw? The hello packet changed from 98 bytes to 150 bytes. So a change of 50 2 bytes, right? 98 to 150, right? Now, if you look at this packet, although you cannot definitively see inside the packet, it's encrypted, but based on what I just told you, this is what the packet looks like. Do you see a duplication over here? It takes a GRE packet, which has a source and destination, and uses the same IP header on the outside. Yeah? This is done because IPSec by default uses a mode known as the tunnel mode, nothing to do with the tunnel interface. The tunnel mode, basically what it does, when a packet hits and ESP needs to encrypt it, it just takes the packet as is without any intelligence, takes a packet and slaps a new header on it and sends it across. This is known as the tunnel mode. This is the default mode. You can see that. Pay attention, guys. This is something that is not well explained in the documentation outside. So over here, if I go onto my router and I do show crypto IPSec SA, you will notice that the mode is tunnel, and the packets that you're seeing over here that are getting encrypted are your EIGRP hello packets. Okay. What's a mode? Tunnel mode. What does a tunnel mode do? It takes the packet as is and slaps a new header on it and sends it across. There is another mode that you can also use. This mode is known as the transport mode. Transport mode is the intelligent cousin. What it does is when you turn on the transport mode, it checks before it starts encrypting the data, it checks the inner and the outer header. It sees that it's going to use the same inner header and the outer header. It checks that. And if it sees the same inner and the outer header, it says, oh, there's duplication. Let me get rid of this. I don't need this. This is a total of 16 bytes. So when you're running GRE over IPSec, you are going to encounter this duplication. You have the ability, if you want, to turn on the intelligence to check the inside header and the outside header. If the inside header and the outside header are the same, it automatically flips over to the transport mode and eliminates 16 bytes. So what it's going to do with the packet is this. I'll show you the packet as well. So this is what it looks like in the tunnel mode, right? Inside header, outside header, the same. Because ESP doesn't look at this. ESP just looks at this as the header. For ESP, this is the inner packet header. For ESP, this guy is just data for GRE. So in the transport mode, you tell the router to check the inside header. If it matches the outer header, eliminate the inner header, which is 16 bytes. When you run GRE over IPSec, ESP will use a tunnel source and tunnel destination as the ESP source and destination. It is recommended to change the mode to transport for GRE over IPSec implementation. And this is what the packet will look like now. What do you guys see over here? What have I eliminated over here? I still have it as a GRE packet, but the IP header, that 199.111 towards 200.111, that part is eliminated. Okay? And by doing that, you'll save 16 bytes per packet. Every packet will have 16 less bytes. Let's see that. To do that, to change the header, the default is tunnel mode, and use tunnel mode instead of transport. When you're doing the normal crypto map, your inner header will be different than the outer header. So that's why they use the tunnel mode. That is correct, Kern. Absolutely correct. And I'll show you that. So first of all, how do I change it? So the next lab I want to do is over here, very simple lab. Configure the existing GRE over IPSec tunnel to use transport mode. That's all I'm doing over here. How do I do it? One command under the, when you did the transform set, mode transport, default is tunnel. That's it. This is the only thing that you need to do. And you could have done it up front. I could have done it up front. The reason I didn't do it because I wanted you guys to see the change. Okay, let's do that. Again, it doesn't force it to do transport. It checks, it brings the intelligence in. If you do transport on the normal crypto map type of configuration, it says, no, 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 this cannot be transport. The inside and the outside header are going to be different. We'll revert back to tunnel. So it has that intelligence. But over here, it's going to help. So if I go to router 1, set it. Router 2, set it. Now for this to kick in, I need to clear my existing tunnel. Otherwise, I would need to wait for an hour. Clear crypto SA clears the tunnel. Clear crypto SA clears the tunnel. All right, now over here, show crypto IPSec SA. I want you guys to see this is a new tunnel, no smaller number of packets. I just initiated it. And in use settings is what? Transport. It is intelligent enough to see that it is a valid configuration for a transport mode. Now coming back to your question, Kern, if I check my tunnel interface, you will see it's still using what? GRE. So the GRE header is still there. Now coming back to your Wireshark, it was 150, remember this? This is old. I'll open the new packet. This is the old packet. No, I'll revert back to tunnel. Over here, take a look. The new hello packet. I cannot tell you, I cannot show you the inside because it's all encrypted. That's the whole purpose, to encrypt it. But now at least I can see what? 134 bytes. Following on, guys? And this is mode transport. And this is what the packet looks like. Overall. Any questions at this point? It is recommended that you set the MPU size to 1420, about 80 bytes is what it takes. No, it's not transport mode automatically. The default mode was tunnel. I needed to change it. Remember? I had to do this. When you change it to mode transport, then the intelligence comes in to check the packet. Otherwise, it just slaps the outer header.